let's see an example of where things can go wrong if we create a hash set or a hash map or any kind of hash-based data structure that includes a mutable type like a list. So what I'll show you is that weird stuff happens if we insert a list into a hash set and then mutate that list. So I'm going to have a running code example on the bottom right where I'm going to create a list of items, which is going to have 0 and 1 in it. And it turns out that if I call items.hashcode on such a list, I will always get back the number 962. Why? Because the array list class, it defines a hashcode method that somehow combines the 0 and 1 into being the number 962. And this code is the way that you can show that. Okay. So with that in mind, if we were to take that list and add it to a hash set of lists of integers, we would take that 962, we would mod it by 4 and we'd get 2, and then we'd go to bucket 2 and we'd insert our reference to this list. So this is some kind of node object, and it has a memory box that points at this list, 0, 1. Suppose we now create a new list that has 2 and 3 in it. So hs.add list of 2, 3, right? So this makes a new list that's 2, 3. Turns out that list has hash code 1026, which if you mod it by 4 also lands in bucket 2. So this is my universe so far. Here's where things will get weird. So let's suppose we have here this items list. If we add a new item to that, then we'll have very strange behavior. So if I do items.add 7, let's say, this list will get changed, right? And that doesn't have anything, as far as the hash table is concerned, there's no change, right? None of these variables changed, this didn't change, this didn't change. The only thing that changed was that this list now has 0, 1, and 7 in it, okay? So this right here, seemingly innocuous, has the problem that everything will not work as we expect, okay? To give you a sense of why, I'd like you to think about this a little bit. I want you to consider the fact that the hash code of a list that contains 0, 1, and 7 should be 29,829. In fact, you can create the list 0, 1, 7, call hash code, and you'll get 29,829. And so the question is, what could go wrong with my hash set? What method call, that is, what method could I invoke on this hash set object and get an answer I don't expect? Okay. So imagine I simply say, hey, hash set, do you have the items array I gave you, or items list? So here's items, I added 0, I added 1, and then I added that list to the hash set, and then I add 7 to the list. When I try and ask the hash set, do you have this list that has 0, 1, and 7 in it? It will say, no, I don't. Now that might seem bizarre, but the reason is that when I say hs.contains items, it takes items, it's an object, and it needs to get an integer representation. What is that integer representation? It's 29,829. If I mod that by 4, I certainly don't get 2, because this is an odd number. And so it turns out that the mod is 1, and so the hash table will look in bucket 1 and say, nothing here. Okay. So this is a subtle issue, and it's easily avoided. The basic idea is that if you have an object that is mutable, and you're using it as a key, you should never mutate it. Otherwise, you get incorrect results for your contains operations, and the item gets lost. And as usual, the failure mode for these kind of things with hash tables, for example, overwriting hash code equals with that hash code, the reason you run into these problems is that the hash table can't find things because there's not a consistent way to locate them, right? It's very important that your hash code is exactly as the semantics of the problem demand. So here, the hash code of this object actually changed when you mutated it, which meant it was no longer possible to find it. Okay? So don't mutate objects that you put inside a hash table, and you'll be in good shape.